Hi, welcome to MathSmart. Today we will be talking about how to multiply algebraic expressions. Before we learn about multiplication of algebraic expressions, let me just recall some concepts that we have discussed in the previous videos. So over here, we would just quickly recall what are the terms in blue called. If you remember, the numbers that we multiply with the variables are called coefficients. And the alphabets in expressions represent variables. Variables keep changing their values. So the simple rule that we learned in the previous videos for adding and subtracting algebraic expressions was when you add or subtract the algebraic expressions, you add and subtract the coefficients. But do remember that we add and subtract the coefficients only for like terms. So if we have like terms that contain the same variable, they all contain an x, they all contain a y, then only we add or subtract the coefficients before them. So over here in my three examples, all of these expressions do not show any like terms because the variables are different. They are x, y, and m. They don't belong to the same family. So now let's see what we can do if we have an example where we are multiplying the algebraic expressions but not adding them. So over here, if you see, I'm trying to multiply 2 times y with another 2 times y and with a 3 times y. If this was a addition or subtraction problem, it would have been easy for me. But how would I be solving this situation? To understand this, let's see how it is happening in steps. Before we start multiplying the expressions, if we know how we multiply the numbers, that's simple enough. That's 2 times 2 makes 4. Now let me bring the variables with these numbers. So each 2 has been accompanied by a y. So this y represents the variable here. And now if we are multiplying them, we are getting 4 times y squared. In the next example, when I'm multiplying 3 numbers, I'm making a 40. But if I'm multiplying all the 3 numbers with a same variable, I'm making a 40y cube. I can make out through these examples that the numbers when multiplied are giving me 4 and 40. But how am I getting the square and the cube on the variable y? Let's try to understand this. How is it happening? So let's see and break the terms. If I am multiplying a y with another y and with one more y, basically I'm multiplying y 3 times. So the number of times I am multiplying y, each time I'm recognizing what was the power of the y that I had in question. The power of y in this question is 1. So each time when I multiply a y, I'm using a 1 and another 1 and another 1. So all the ones I added together and I made a y cube. Another example will make things little clear. If I'm multiplying a p 4 times, I know I'm multiplying the same variable 4 times, but when I multiplied the p each time, the power was just a 1. So I just club all those powers by adding, and I say my answer will be p to the power of 4. On this note, for these two examples, my simple rule should be, while multiplying the same variable, I add the powers. So there are two things to be noticed that I'm multiplying the same variable. It was either a y each time or a p each time. And when I added the powers, it was only because the same variable was being multiplied. But what if we have to multiply the same numbers and variables together? So let's have a look. I am multiplying 2 times m with 10 times n. So I have two things here. For each expression, for each part of the multiplication sentence, I am having two values. One represents a number and the other represents a variable. So in simple rules, I will be saying multiply the number to the number. Since you remember that they belong to the same family, the like terms. So 2 multiplied to 10 makes a 20. And now I apply the same rule that I learned on my previous page, m times m. As I'm multiplying m with the power m, 1, and with another power 1, that makes a 2 together. So I added the 2, 1 and 1, that made 20m squared. Next case. I have three numbers which multiply to make 70. But there is something different. Over here, the variable is same in just two of the cases. So what I do, I just notice how many p's do I have to multiply. So there was p with a power of 1 and p with a power of another 1. So when I added the powers, I got p squared. The last term had an n, which was not a like variable. So the n came as it was with the same power 1. So even if you see, if I don't even write a 1 here as a power, it will still remain a power 1. Let's see how we have understood this. So the numbers are written here in the blue and the variables are all in red. So in the first example, 4 times 2 times 5, 40. Without even noticing what the variables are, I simply multiplied the numbers and I made a 40. In the second case, I made the numbers multiplied to 240. And in the third case, I'm just multiplying all the numbers without noticing the variables, and they finally make a 24. Now let's see how I'm dealing with the variables in each case. In the first case, I had three expressions. Two of them have an A, but the third one has a B. So I just add the A's with their powers to find out my answer. I got A cube. Since I had a 1A and two more A's, that makes A cube. And the B was without any pair, so it is still alone. In the next part, I'm having two terms with A's and the two middle terms have a B. So what I do is I just take carefully the A's together first. So my A square and A cube from the first and the last term add to make a 5 as a power for A. And my B square and my B together make a 3. That goes as the power of my answer on the right hand side. Similarly, in the last part, if I take the A's first, 1A here, 1A here, and square here. So I say 2 plus 1 plus 1 makes a 4. So A to the power of 4. And in the last case, I have B square and B to the power of 1. That makes 1 plus 2, 3. So here it goes. I hope the simple rule of keeping the powers added when the variables are same should make multiplication of algebraic expressions simple and clear for you. I will be coming up with more videos to help you multiply algebraic expressions when there are more terms. Until then, keep checking for more videos and keep liking Math Smart. Thank you.